27 in our review of descriptive statistics and probability. It says, assume that females have pulse rates that are normally distributed with a mean of 72 beats per minute and a standard deviation of 12.5 beats per minute. And we're going to compute some probabilities, and since things are distributed normally, we're going to use the normal distribution. So I'm going to open up StatCrunch. I'm going to go to my calculators, so Stat, Calculators, and I'm going to use the normal distribution. And so here the mean is 72 beats per minute, and the standard deviation is 12.5 beats per minute. If one adult female is randomly selected, find the probability that her pulse rate is less than 76 beats per minute. So here, I'm already, probability x is less than or equal to, and I'll say 76 and press compute. And so I'll find the probability to 4 decimal places to be 0.6255. Okay, now in this case, if 25 adult females are randomly selected, find the probability they have pulse rates with a mean less than 76 beats per minute. So they're asking essentially the same probability question, but not about the individual that is selected at random, but the sample mean from a random sample of 25 females. So in this case, if we'll remember, the standard deviation for the sampling distribution is going to be the standard deviation of the population divided by the square root of the sample size. So the square root of 25 is 5. So 12.5 divided by 5 is 2.5. So now, to answer this question, I'm dealing with a normal distribution with the same mean of 72, but now when I take 12.5 and divide by the square root of 25, I get a new standard deviation for the sampling distribution to be 2.5. And so I'm still trying to find the probability of this sample mean being less than or equal to 76. Press compute, and now that has changed. So to 4 decimal places, the probability is 0.9452. So why can the normal distribution be used in part B even though the sample size does not exceed 30? So here they're trying to have you recall the central limit theorem. And the central limit theorem says that even if the population is not normal, as long as your sample size is 30 or larger, then you can believe that the sampling distribution would be approximately normal. All right, but in this case, what we know is the original population was normally distributed. It was normally distributed, and so any size sample will work. So if you look at option D, since the original population has a normal distribution, the distribution of sample means is a normal distribution for any size sample. So I could have sampled 5, 10, 15, 20, any number, and the sample means would have behaved normally. But that's only because the population was assumed to be normally distributed. I hope this helps.